Okay, seventh graders, you're going to have a test coming up pretty soon on two-dimensional area and perimeter. And the fancy word for perimeter of circles is circumference. So let's start off with the concept of area. We're going to go through all the different shapes that you might have and some combined shapes. And we'll go pretty fast, but that's okay because you'll be able to stop and rewind the video and watch again, and then I'll go through some of the problems that would be on like a practice test and so forth. So let's start off with area, okay? And the basic concept of area is how many little 1 unit by 1 unit squares fit into a space. Now I'm not going to draw everything perfectly, but this is 1, 2, 3 units wide and 1, 2 units high. And this is a rectangle, all right? And so you can see there's 1, 2, 3, 4, 5, 6, and we're assuming those are all exactly the same size, all 1 by 1. There's 6 unit squares. If they were inches, the area would be 6 square inches. Not 36 inches, 6 inches that are little 1 by 1 inch squares. It can be written like that, or it can be written as just like 6 SQ inches, okay? So that's the basic formula for area is the base of a shape times the height of a shape. It doesn't matter what you call it. You could call that the length times the width, or the length times the height, or the width times the height. It doesn't really matter. It's just for a rectangle, it's one dimension times the other dimension, okay? And the basic unit there is a rectangle, all right? And the word rectangle, actually, that word right there, when you're correct, you're right. The word rect means right angle. So a rectangle is a shape that has 4 right angles, okay? 4 90-degree angles. Okay, really fast, we'll just move on to the next shape. What if you have a similar shape? I lost my eraser. There we go. I'm back with my eraser. What if you have a similar shape, but it's not a rectangle? Maybe it's like a parallelogram, and let's say it's almost exactly the same size. Well, really, if you think about it, if this is a parallelogram, it's called a parallelogram because it's got 2 pairs of parallel sides, just like a rectangle. A rectangle is a parallelogram. If you cut off this little triangle piece and slap it on over here, what do you have? You have a rectangle. So the idea is, for a parallelogram or some other shape like that, you've got the same area. So you use the same formula. The only way it can get a little bit confusing is if you're not given the height, right? These lines, you don't measure height diagonally, so someone like me would need to give you what's called an altitude, or a drop-down line that goes from the bottom to the top, and it tells you the height. So again, if this were 3 units wide and 2 units high, right, I'd put a little right angle there to say that I'd go directly straight up, then the area would still be 6. Now I'm not going to put square units on everything from this point forward because you know it's supposed to be 6 little squares that fit in there. Great. So now we have rectangles, parallelograms. All right. All rectangles are parallelograms. Not all parallelograms are rectangles. Squares are also rectangles because they have 4 right angles. It's still the base times the height. Let's just say, I don't know, I'll give you a different number. If that's 5 and that's 5, the area is 25, okay? So all squares are rectangles, but not all rectangles are squares. Let's do a triangle. All right, now a triangle, if you really think about it, what I always like to say is a triangle ain't nothing but half a rectangle. So really, to find the area, how much space the triangle takes up, it would be how much space the pretend rectangle takes up divided by 2. Or again, base times height, or length times width, whatever things you want to use. So let's say this is 4 and this is 3. Okay, so the area of the triangle would be 4 times 3, which is 12, divided by 2. So the area would be 6. Sorry, I keep having my areas come out to the same number. Remember, I'm not measuring these things. I'm just kind of making up distances. They could be centimeters, they could be yards, they're imaginary distances, all right? So, area for a triangle, the formula for the area of a triangle is, base times height, or length times width, divided by 2, okay? Because it's half of a rectangle. Now, what if it's not a nice right triangle like that? What if it's this kind of a triangle? Well, that's okay, because again, it's not half a rectangle, but it's half a parallelogram, and so it's the same thing. Base times height, because that's how you find a parallelogram, and then you divide by 2. And again, I would have to, or the book, or the test, or whatever, would have to give you an altitude. Let's use some different numbers now. And again, not drawn to scale. I'm just making up numbers. Say this is 10 and this is 6 units high. So it would be 10 times 6, which would be 60. But remember, it's a triangle. So the area would be 30 square units. All right? Units with a little square on it. Okay? Meaning little 1 by 1 squares. Okay, great. All right, so we got rectangles, squares, parallelograms, triangles. Okay, now, sorry, I dropped my eraser here. We're going to do another shape, and it's called a trapezoid. And what a trapezoid is it's one pair of parallel sides. Those are parallel, but the other two aren't parallel. Well, that's okay. So my method for solving this is a little different than maybe some others, but here's the thing. If you lay this shape right here, let's call this the base, and we'll say that's, I don't know, 10 units. This is shorter, right? Let's make up a number. Let's say that's 6 units. Let's say the height, I got to give you an altitude, so you know the height. Let's say that's 3 units. Okay. Well, if I did base 10 times height 3, it's not a triangle, I'm not cutting in half, then that would give me 30, but that would be the area of that rectangle, which that rectangle is bigger than my trapezoid, right? It takes up more space. There's these little pieces that we have to deal with. So you're thinking, okay, this base of 10 creates too big of an area, so maybe let's flip it upside down and go like this and put the 6 as the base. But guess what? If I put the 6 as the base, this is still 3. What that would give me is the area of a little rectangle right here. Okay, with that being 10 across. Then I'm not taking into account those little flaps there. So just like Goldilocks, if 10 is too big and 6 is too small, we find the base that's just right, which would be the average of these two, which of course, what's right in between 10 and 6? 8. So find the base that's just right, then you times it by the height, okay? So in this case, it would be 10 too big, 6 is too small, 8's just right, times it by the height, and you get 24. Now there is a formula for a trapezoid. The formula for the area of a trapezoid is base 1, meaning like the 10, plus base 2, meaning like the 6, divided by 2. And all that does is find the average of 10 and 6, right? When you add two numbers and divide by 2, you get the average. And then you times by the height. Okay, so it'll be 10 plus 6 is 16, divided by 2, times 3, which of course is 24, which we already knew. Okay, and again, it would be square units. Now you know rectangles, triangles, parallelograms, trapezoids. Okay, there we go. Now there's a special shape where all these formulas don't really work. And that special shape is a circle. The problem with a circle, I'm going to make it as round as I can. It's not bad. Okay, the problem with a circle is when you're trying to figure out how many little squares, 1 by 1 squares, fit in this space. Well, if you were actually to put this on a grid, right, and try to like figure out how many little squares, you're going to get all these little weird, curvy pieces of squares that, how do you find that? So you can't really do any kind of base times height kind of thing. But luckily, there were mathematicians that came ahead of us, and they gave us a special number called pi. Now, pi is, everybody knows, it's approximately 3.14, 3.1415926535897 and something else after that, I don't know. Okay, but it's a ratio. It's funny because it's irrational, it doesn't go on, but it's a ratio of the distance around, which is called the circumference, to the distance across, which is called the diameter. Now, I kind of got off track on area a little bit for a minute, but that's okay. I wanted you to know what pi was. If you took any circle, wrapped a string around it, measured the distance around, and then measured the distance across, and you divided them, you'd get essentially 3.14-ish. Now, you know, there's human error when you're measuring, but try it sometime. It's fun. You'll get the same, whether it's a giant tire that you do around and across, or whether it's a penny, or whatever it is you do, the ratio is the same. All right, we're back to area. Okay. Now, area, there's a formula that was given to us, okay, by the Greek mathematicians, and it makes it really easy, and we say the area of a circle is pi times the radius squared. Now, the radius is halfway across the circle. From the center to the outer edge is called a radius. It doesn't matter which direction you go, it'll be the same. From there to there, from the center to the outer edge is always the same. So the radius, all radii are the same length. Okay, so really simple. And what we get to do, we get to use pi like a variable. If this is 5, I don't know, inches, then the area is 5 squared, which is 25 times pi. And what I like to do is, hey, let's use pi like a variable, like 25x, but 25 pi. Okay? Yes, I know you could take 25 and multiply it by approximately 3.14, but why bother? Let's just call it 25 pi. We know that's about 78-ish or something. Okay, so we're going to kind of use pi like that. Okay, so here's another one. All right, another circle. And if that's 7, of course, I know, remember I'm not drawing to scale because that is smaller than that, but just pretending, I don't know, different units, centimeters, whatever they are, the area of this would be 49 pi. Okay, there we go. That's it. You got all your flat shapes. Your triangles, your rectangles, your trapezoids, your parallelograms, your circles. The only thing left to do for area of two-dimensional shapes is maybe combine some of them. So, for example, you might get a shape like this. Oh, it's terrible. I'm pretending that's a rectangle with a little half circle on top. Okay, well, all it is, how much space does it take up? Well, it's how much space the rectangle takes up plus how much space the half circle takes up. That's it. Okay, so let's say that this is 10 units wide and this is 12 units high. Well, how much space does the rectangle take up? Easy. Base, 10, times height, 12. 120. How much space does the half circle take up? Well, I don't know the radius. Well, look, this is part of a rectangle and this is right here, so it's 10 across there, which means halfway across would be how many? 5. All right? And so the area of a whole circle would be 25 pi, right? Plus 25 pi. But oops, I forgot something. This is not a whole circle, is it? It's a half circle, so I'm just going to divide it in half. 25 pi over 2, right? Which is 12.5 pi. And we can leave our answer like that. Right? Remember, these are pi's, these are regular numbers. These are ones. These are 3.14s. You cannot say that's 132.5 pi's because they're not the same. They're unlike terms, going back to combining like terms. That's it. That's area. Okay? There's one. Oh, wait. No. We got to go a little bit deeper. Okay? Shaded area. There's one on a practice test where you got like a square and you have a circle inside. And then all this is shaded right here. It's a really ugly job that I'm doing here. Okay, but let's say, I don't know, this is a 20 by 20 square. Well, what's the shaded area? Well, it's easy. It's the area of the square minus, it's like I poked a hole in the middle, minus the area of the circle. Well, what's the area of the square? 20 by 20, right? Base times height. 400. By the way, I asked you to memorize your first 22 squares, right? What's 17 squared? 289. You got to know that. What's 19 squared? 361. 20 squared? 400. Squared means times itself, okay? That's why this is called a square. All right. Anyway, 400 minus, what's the radius of that circle? I know what it is. If it's 20 across there, then that's 10. And 10 squared is 100. So minus 100 pi. That's the shaded area. That's roughly about 314-ish. But we can leave it like that. Great? Good. Area of two-dimensional shapes. All right? You got all your shapes. Follow the formulas. If there's more than one shape that's part of a giant shape, add the shapes together, right? I could slap a triangle on the bottom of that one, and then I'd have to give you enough information. You'd have to add the rectangle, the half circle, and the triangle, okay? Pretty easy stuff, okay? And then I got one more thing, and it's called a sector of a circle. You should be really good at this because we just did half circle, and that's really a sector of a circle too. It's half of a circle. But let's say I've got something like this, and then that's a, I don't know, 45-degree angle. Not measured very well because that's definitely more than 45, but that's okay. All right, that's a 45-degree angle. And I got this little pizza slice here. Right? It's a piece of a circle. And let's just say, I don't know, the radius here is 4. Well, again, if it's a piece of a circle, then that's 4 also. All right? And so what I have is a part of a whole circle. What part? Well, how many degrees is it? All the way, that's a terrible circle, but how many degrees is it all the way around the circle? 360. What piece of degrees do I have? I've got 45. Remember your vocabulary, your mathanese. I've got 45 out of. 45 out of 360. 45 3/60ths. of is multiply the whole circle, which is the area of the circle is pi r squared. Now, you could do some reducing, right? We got to get good at our, basic math skills. Like, is there a number that goes into both 45 and into 360? As it turns out, we could work with 9, let's say. 9 goes into that 5 times. 9 goes into that 40 times. Ooh, we could reduce it even further. 5 goes into that once. 5 goes into that 8 times. Okay, so we have 1/8 of times 1/8 of the whole circle. What would be the area of the whole circle? It would be pi r squared. R is 4. 4 squared is 16 times pi is 16 pi. So it would be 1/8 of 16 pi, which is 16 pi over 8, which is 2 pi. And again, we can leave it like that. That's how you find a sector area. Do one more really fast. All right, let's do go like that, and like that, and like that. I'm going to say that's 120 degrees. And let's say the radius is 6. All right, well, what do I have? I have, let me erase this right here. See, you get the whole video. You get the erasing and all that part, right? You don't get the edited version. We don't want all that. All right, so what we have is a part of a whole circle. We have 120 3/60ths. That's the part of the whole, right? If it was all the way around, it would be 360. We've only got 120 degrees, so we've got 120 3/60ths of pi r squared, which is 36 pi, right? And then again, we could look at this. Watch some fancy reducing. We could kill zeros right there. We could kill 36s right there. And look at that. 12 times pi over 1, 12 pi. All right? If you can't go that fast, that's okay. You could reduce that down. It ends up being 1/3 of 36 pi, which is 12 pi. Okay? Yay! You know how to find the area of any flat shape in the world, right? Just combine shapes, cut shapes off, add them, whatever you need to do. There we go. And we're going to come back in a minute and do perimeter / circumference.